Alright, geometry students, welcome back to our second lesson here on trigonometry. This is second out of several lessons. Last time, if you remember correctly, we went ahead and started looking at what was called standard trigonometry. We were finding missing sides of triangles. And we did several things here. If we started out by identifying opposite, adjacent, and hypotenuse in a triangle, and then we were able to find missing sides of a triangle as well. For example, looking at these warm-up problems here, if we're concentrating on angle Q with respect to angle Q here, we always know that the long side of any triangle is going to be considered the hypotenuse. We can label that hypotenuse. The side that touches the angle that is not the hypotenuse, we're going to call the adjacent side. And then the side that doesn't touch the angle at all, the one down here, RS, we would consider the opposite side of the triangle, or opposite side of the angle. We can use these facts, for example, when we're looking at the triangle in the second problem, by concentrating on the angle that we know 62 degrees down here, we can identify that we know the opposite side, the side that doesn't touch our angle. We want to know BD, we want to know the hypotenuse, the long side. Now writing out our SOHCAHTOA, we can go ahead and say, well, we know the opposite. We want to know the hypotenuse. Which trig function helps us out with the opposite and hypotenuse? Sine helps us out with opposite and hypotenuse. We could set up a trig function then. I'll go ahead and write in green here. We can set up a trig function. Sine of our angle, 62 degrees, is equal to our opposite side, which is 11, divided by our adjacent, or our hypotenuse. We don't know how big that is yet. We'll just call it BD. And here we have our equation. Sine of 62 equals 11 over BD. On our calculators, if you go ahead and type in sine of 62 degrees on your calculator, that is going to give us a 0.883 approximately. 0.883. 0.883, we could say 0.883 is equal to 11 over BD. From here, of course, we can add a 1. I'm going to go ahead and add a 1 to the bottom of this side of the equation and cross multiply. On the one side, we'll get 11. On the other side, we'll get 0.883 BDs. As a very last step here, if we divide both sides by 0.883, I'm going to go ahead and assume you know how to do that. Divide both sides by 0.883. We could say that BD is equal to, and I'm going to put into my calculator, 11 divided by 0.883. You can go ahead and do that with me there. 11 divided by 0.883 gives us about a 12.46, approximately 12.46. As soon as we're done with our problem, make sure to check if that answer seems reasonable. BD, it looks like, seems like it could be about a 12.46 since this side, CD, is 11. It seems very reasonable that this side would be over 11. About a 12.46 seems pretty reasonable. Today, we're going to extend our knowledge of trigonometry. Last time we did trig, finding missing sides. Today, we're going to find missing angles. Goals for today: by the end of today, you're going to be able to eliminate trig functions by applying inverse trig functions. You'll be able to compute missing angles given a couple of sides, and you'll be able to know which trig function to use in which situation. Inverses. You've been using inverses for a long time in your school career. Inverses undo each other. They're opposites of each other. For example, addition, the opposite or the inverse of addition of adding 7 would be subtracting 7. Similarly, the opposite of subtracting 4 would be adding 4. Dividing by 8, you can guess that, is going to be multiplying by 8. And squaring, the opposite of squaring is going to be square rooting something. If you square root something, it gets rid of a squared. Inverses are very nice because if you have an equation, let's say x plus 7 is equal to 10, we know that adding 7 and subtracting 7 are inverses of each other. To get rid of that plus 7, we would go ahead and just subtract 7 from both sides, and that would eliminate the 7 on the left side. Tangent, sine, and cosine all have inverses as well. If you look on your calculators, I'm going to go ahead and clear my screen here. If you look on your calculators, let's see here, calculator. I'm going to pull up my calculator in just a minute here. There are three different trig functions that you'll see right on top of your sine, cosine, and tangent buttons. You're going to see something that says tan -1. You're going to see something that says cos -1. And you'll see something that says sin or sine -1. Those are going to get rid of the sine, cosine, and tangent in our equation. Give me a moment here and I'll go ahead and pull up a calculator to show you what that looks like. Here we go, right on top of your calculators, at the very top here, sine, cosine, and tangent. If you'll notice, on the very top of my sine button, I have sine inverse, cosine inverse, and tan inverse. If you go and type that in, second button on the top left of your calculator there, and then sine, you'll get sine inverse. What I want you to do real quick is make sure your calculator is in the correct mode. Do a sine inverse of 0.05. Rather, let me take that back, 0.5. Do a sine inverse of 0.5. Hit enter. If you do not get 30 degrees back out, then your calculator is in the wrong mode. You're going to have to hit that mode button and then switch it over to degrees. Luckily, I was already in degree mode. Like I said, we can use these to eliminate, to get rid of sine, cosine, tangent. In this first equation that we see, we have a sine of A is equal to a 5 over a 12. I'm going to go ahead and write that 5 and 12 a little farther over here, 5 over 12. In order to get rid of sine, I can go ahead and use sine inverse on both sides. Sine -1 on this side, and then similarly here, sine inverse on this other side. The sine and the sine inverse are going to get rid of each other. Just like a +7 and a -7 get rid of each other, sine and sine inverse get rid of each other completely, leaving us with just, let's switch over back to red, just A on this side. On the other side, if you type in sine inverse of 5 over 12 on your calculator, you can type in sine inverse and then 5 divided by 12 on your calculator. That's going to give you about a 24.6. All right, about a 24.6. That means that this equation, this angle is going to be 24.6 degrees big. I want to show you that on the calculator as well. Unfortunately, I need to clear my screen. Let's remember sine inverse of 5 over 12 is 24.6. Sine inverse of 5 over 12, I'm going to type that into my calculator here, sine inverse of 5 over 12, and we are going to get 24.6. How is this actually used in a triangle? You can do this on your own, this next one on your own, but this next one here, how is this actually used in a triangle? If we have a missing angle D, suppose we have a missing angle D up here. We don't know how big it is. We could approximate that it looks bigger than 45, less than 90, maybe 60 or 70-ish, somewhere around there. We can label our sides. This side that's labeled 7 is the opposite to angle D. This side that's labeled 3 is the adjacent to angle D because it touches angle D. And then this other one here is the hypotenuse, but we don't care about the hypotenuse right now because it's not labeled with any size. Looking back at our SOHCAHTOA, which trig function helps us out with using adjacents and opposites? Well, tangent helps us out with that one. We can write tan of angle D is equal to our opposite side, 7, divided by our adjacent side, 3. I knew to do the opposite side on top because the O comes first before the A, adjacent side on the bottom. On both sides now, we can tan inverse both sides. Tan with a -1 on your calculator will be tan inverse. And we'll go ahead and do that to both sides of our equation. Tan inverse on both sides. Plugging tan inverse of 7 over 3 on your calculator now. I'm doing that right now. You can do that with me. That's going to give us a 66.8. All right. On this side, we'll have a 66.8 degrees. On this other side, tan and tan inverse are going to get rid of each other, and we're going to be left with just angle D is equal to 66.8. That means this angle right in here, 66.8 degrees. Now I'm going to take a moment to show just a white screen because I want to point out something kind of interesting. Try taking the sine inverse of 5 over 3. Sine inverse of 5 over 3. If you do that on your calculator, go and do that with me on your calculator. Sine inverse of 5 over 3. Your calculator is going to give you error. It's going to say error. We can't do sine inverse of 5 over 3. I'll show that on my calculator here. On this calculator, if I take a sine inverse of 5 over 3, error domain. It doesn't like sine inverse of 5 over 3. So what can we do? Well, if I go ahead and pull my text back, sine inverse of 5 over 3, what does that actually mean, sine inverse of 5 over 3? Well, it means that we have a triangle that's proportional to a triangle. That if we take an angle here, concentrate on this angle, the opposite, remember sine is opposite over hypotenuse, the opposite side would be of length 5, the hypotenuse would be of length 3. Why can't that happen? Well, a hypotenuse needs to be bigger than an opposite side. If opposite side's 5, hypotenuse is 3, that can't happen. So your calculator is saying that that triangle cannot possibly exist. How does this apply to real world, you might ask? We can find missing angles. I got to go on a couple of trips over the course of J-term, and I always had faith in my pilots that they'd be able to calculate the angles successfully and land our plane. Suppose that a plane is coming in. It is currently has an altitude of 500 feet, and it needs to travel another 9,000 feet forward before it lands. And it's going to land on an airway somewhere over here. What angle does this plane need to come in at for it to have a successful landing? Well, we don't know this angle. I'm going to just label it angle A. We don't know what angle it is yet. However, we do know the opposite side here. I'll switch over to green. We do know the opposite side. We do know the adjacent side. Opposite and adjacent signify we're going to use tangent. So I can go and write tan of angle A is equal to 500 over 9,000. I can take the tan inverse of both sides and say this is tan inverse of 500 over 9,000. And then putting that in your calculators, angle A is equal to the tan inverse of 500 over 9,000. We're going to get that that angle is about a 3.2 degrees. That means this angle right in here is a 3.2 degree angle. Very small, but hopefully that makes sense since I'd rather not have an airplane traveling downwards at 60 degrees. You don't want to fly that far. You know somebody's just going to fly out of their seats. They didn't pay attention to the seatbelt signs, and that would be a travesty. Going back to today's objectives, you will be able to eliminate trig functions using trig inverses. I think we covered that. You'd be able to compare missing or compute missing angles given a couple of sides. We did that a few problems ago, similar to this one. And you'll be able to know which trig functions to use and when. Always use SOHCAHTOA to find those. As always, if you have any questions, email me. Hopefully you enjoyed the lesson. Have a wonderful evening.